Hello everyone and welcome to our presentation. After forming our group, we came together as a team to talk about our BootCon topic. One of the topics we found interesting was phishing because of how it is quite a common malicious attack to which many people fall victim to every day. As phishing emails are designed to exploit human errors and security gaps, we thought it would be fun to try and phish our classmates with a phishing email. Since we had all used our personal emails for Azure for the cloud security module, we thought it would be a good idea to try and phish our peers with an email from Azure saying that they should click a link to avoid being charged additional fees. But before we could do that, we had to make sure that we were allowed to do so, which is why we took Omar on board and asked his permission. He told us we could, as long as we got our email approved with the content having no malicious links. Omar also said that he could not give us the email addresses of the class, which is why we conducted some open source intelligence, OSINT, to gather the relevant information. We used LinkedIn as well as Google searches to find email addresses of our classmates, as well as ask them to provide it themselves on a Google Sheet. Sorry guys, we meant no harm. We will still use the emails and LinkedIn profiles to connect in the future. It seemed like creating a phishing email campaign and sending the phishing emails would be an easy thing to do, but we ran into several problems from the get-go. Our domain got banned by GoDaddy, the emails were landing in spam/junk folders, and it was quite a lot of work to configure all the SSL certificates and other settings.
After collecting email addresses, we began setting up our GoPhish profile, which was initially configured on a Guacamole VM. GoPhish is an open-source phishing simulation platform designed to help organizations train employees on cybersecurity awareness. It allows users to create and send custom phishing campaigns, track responses, and analyze data to improve defenses. During our first test campaign, we discovered that GoPhish requires integration with an existing email address for sending emails. We used a personal Gmail account as the SMTP server, but quickly realized that Gmail does not allow email spoofing when used in this capacity. This limitation prompted us to explore alternative solutions, leading us to SendGrid, a scalable and reliable SMTP relay service that simplifies email configuration and delivery. We created a SendGrid account, authenticated our Gmail address, and integrated it into the GoPhish sending profile. However, while SendGrid verified the email address, it still did not permit email spoofing.
To address this challenge, we purchased a custom domain, azure-support.info from GoDaddy. We then set up a virtual machine using DigitalOcean. DigitalOcean is a cloud infrastructure provider that offers scalable and cost-effective solutions for developers, startups, and businesses. It provides virtual servers, droplets, managed databases, object storage, and developer-friendly tools to simplify deploying and managing applications. We installed Linux on this virtual machine with a configured network firewall that restricted access to a limited set of personal IP addresses for enhanced security. We authenticated the new domain in SendGrid by adding the required CNAME and TXT records from SendGrid into our GoDaddy account.
Another issue we encountered was that the virtual machine running GoPhish would shut down whenever the terminal was closed. To address this, we created a systemd service for GoPhish and its related directories. First, we established a new system use called GoPhish to run the service securely. Then, we wrote a service configuration file, etc systemd system gofish.service, to trust the system on how to start and manage GoPhish. Additionally, we created a log directory and set the appropriate permission for both the GoPhish files and the logs. To enable GoPhish to use port 443, we assigned special capability to its binaries. After reloading systemd to apply these changes, we enabled and started the services, verifying that it was running smoothly. During testing, we noticed that emails sent from support@azure-support.info were flagged as a spam by Gmail and Outlook, especially when the email body was left blank. These emails were not delivered at all and to any Hotmail or Outlook addresses.
This showed that Microsoft had a good filter in place to prevent the phishing emails from reaching their users if they were coming from suspicious addresses that included Azure in the domain or username. Even after modifying a TXT record to include the sent red net, all the emails they failed to reach the inboxes, showing that commonly used email services like Gmail and Yahoo have a good spam filters in place. To improve the delivery, we had content to the email body, and this change allowed us to successfully send emails from support Azure support info to the personal Gmail and the Outlook addresses. However, just 6 hours later, our GoDaddy account was flagged for malicious activity and subsequently shut down, leaving us without access to the domain or account. This made us realize that GoDaddy already has some robust protocol in place to identify malicious activity that might be done.
So a few days later, we bought another domain on GoDaddy called supportstaff.info so that we could use it to send actual emails and configure the landing page for the phishing email. We use card.co, a free service for building a fully responsive one-page site to create a static landing page that the email recipients would see if they fell for our phishing attempt and clicked on the malicious link. We decided not to use the Azure template in case it would get blocked again, and instead use two different options, one from a fictional cybersecurity summit and one from Splunk. When we ran a test, we realized that many emails were not being delivered to the Microsoft accounts, and few that did went right into the junk folder. For Yahoo, all of them were going into spam. For Gmail though, they were all delivered right to the inbox. However, the link to the static page was not working, which was because we realized that the value for the use_TLE for the phishing server was set to false in the system.json file. Changing it to true is what made the phishing link work. Next, we ran 2 campaigns and sent them to our class. For each campaign, 31 emails were sent. For the Splunk email, 21 people, or 68% of the class, opened the email, and 6 people, 29% of the class, who actually opened the link. For the Cybersecurity Summit email, 20 people, 65% of the class, opened the email, and 6 people, 30% of the class, opened the actual link. So with those numbers, roughly about 30% of the people that opened the emails also clicked the link, which is a significantly high number.
So all the while this was going on, our team was also working on the phishing emails, detecting script in Bash. The script was designed for use on an organization's internal email server, where most of the communication is done on emails hosted on the organization's private domain. It is designed to be used by the IT departments as an audit tool, testing environments, as well as educational purposes for the employees. The script creates a warning when potential phishing emails are identified. The script first uses fetchmail to import emails into Linux from the specified username and service, which we, along with the IMAP information, put in .fetchmailrc. The script then scans the email headers for suspicious domains, the email body for dubious and generic greetings, or creating an unnecessary sense of urgency. And it also checks if there are any malicious and harmful links, URLs, and/or attachments to the email. So let's go over how the script works step by step. First, the script defines several functions to perform specific checks. The check_sender function examines the sender's email address to determine if the domain belongs to a list of potentially suspicious and external domains like gmail.com, yahoo.com, or outlook.com, as these are the most commonly used domains used in phishing. If the domain matches one of these, it flags the email as potentially suspicious. Next, the check greeting function analyzes the body of the email to identify generic greetings commonly used in phishing attempts, such as Dear Customer or Dear Sir/Madam. The check links function searches the email body for URLs, extracting them and analyzing them whether the links contain terms like pay or secure, login or update, verify, account, or bank, which are often used in phishing scams.
Similarly, the check attachments function inspects the email for attachments and checks their file extensions. If it encounters files with extensions commonly associated with malware, such as exe, src, zip, bat, cmd, vbs, or js, it marks the email suspicious. The check urgency function looks for phrases that convey urgency or threats, such as immediate action required or your account has been suspended, as these are typical in phishing schemes to pressure the recipient into acting without thinking. The analyze function combines all of these into a single process, for a given email. It calls each of the individual checking functions, runs them sequentially, and evaluates their results. If any of the checks return a suspicious result, the script warns the email might be a phishing attempt. Otherwise, it declares the email is safe. This function also outputs details about the sender, subject, and the results of the analysis. The script then processes emails from /var mail sysadmin, which is where the fetch mail stores all of the fetched emails. It first ensures that the email file exists, and then identifies the starting lines of the first 30 emails using awk. For each email, it extracts the sender's address, subject, email body, and any attachments. These components are parsed by the analyze email function for analysis. The script uses commands like grep, sed, and awk to parse the email content efficiently. Let's take a quick look into how the script works in action.
I've also made it an alias as well on bash. So if I just use phishing check, it'll actually analyze everything. It's very simple.
So now if we let it run without doing any /c's, it should pull 30.
Oh, amazing. There it is.
Yep.
Our experience of creating a phishing simulation and detection script used many lessons learned throughout our cybersecurity course, including OSINT, configuring a virtual network, setting up SSL certificates, and bash scripting, helping us better understand phishing and its mitigation.
We learned that it's not easy to create phishing emails as we faced barriers such as domains being flagged and emails landing in spam folders. We found that Microsoft had the best spam phishing filter, with Yahoo coming in second and Gmail last.
Configuring a virtual machine and using tools like GoFish and SendGrid gave us a better understanding of why certain junk emails land in our inbox instead of spam folders, and what techniques malicious actors might use to ensure that emails look as legitimate as possible.
The development of the phishing detection script in bash helped us better to understand the value of automated tools in combating phishing. This aligned with the real-world implication of using automated detection tools to identify threats and to respond swiftly to them.
Another lesson was the ethical aspect related to cybersecurity, as we had to seek permission to run our phishing simulation on our fellow classmates, while also ensuring that the ethical use of the collected data and that no harm was done.
We also learned the importance of teamwork. Our group played both red team and blue team, with the red team running the phishing campaign and the blue team creating the detection script. Together, we were able to overcome barriers and hurdles we faced and brainstorm to come up with creative solutions to the problems we encountered.
Phishing is currently a significant threat, and it is likely to continue to evolve and remain a problem in the future. This project helped us better understand the importance of continuous learning and adaptation in the cybersecurity field.
By applying course methodologies to simulate attacks and create the detection script, we were able to develop a proactive mindset crucial for addressing dynamic cyber threats in the professional settings. The experience was not just an academic exercise, but a preparation for real-world cybersecurity challenges, making us more adept at protecting systems and users alike.